Student, in last period we already studied the Newton's law of motion. In last period we completed the first and second law. Second law is related to a momentum. Momentum is the product of mass multiply velocity. That is P equal to m into v. आपण तो नियम या ठिकाणी सांगितलेला आहे. The rate of change of momentum is directly proportional to applied force and the change in momentum occurs towards the direction of a force. From this law we explain the formula of a force. Force is equal to mass multiply acceleration. F equal to ma. The SI unit of force is a Newton and CGS unit of force is dyne. These two laws already we have to completed in last period. Now we are going to start the Newton's third law of motion. The statement of Newton's third law of motion is as every action force has equal and opposite reaction force which act simultaneously. Look at this. The third law is an important law. Every action force has an equal and opposite reaction force which act simultaneously. Means action and reactions are simultaneously occurs in Newton's third law of motion. Most of the examples are related to in our routine life, in a general life. We have to take some examples related to Newton's third law of motion. In Newton's third law of motion, explained action and reactions are simultaneously occurs and they are opposite to each other. The statement is as every action force has an equal and opposite. Look at this word equal and opposite means any reaction which is a simultaneously occurs. Action and reactions are simultaneously occurs. If we bite the mosquito, immediately we have to fly from the mosquito. We have to fly the mosquito from our hand. Some examples related to Newton's third law of motion we have to explain as number first, mechanism of firing of a rocket. Look at this. The first example, mechanism of firing of a rocket is the example based on Newton's third law of motion. Action and reactions are simultaneous occurs in this example. Second, when bullet is fired from a gun, then gun moves in a downward direction, moves in a backward direction, because action and reactions are simultaneously occurs in this example. Third, when hitting a ball with the help of a bat, the speed of a bat decreases. In a cricket match, when a player hitting the ball with the help of a bat, the speed of a bat decreases. Means it is an example of Newton's third law of motion. In each example, action and reactions are simultaneously occur. Every action has an equal and opposite which acts as a simultaneously. So Newton's third law of motion, the statement is as every action force has an equal and opposite reaction force which act simultaneously. Example, mechanism of firing of a rocket. In Diwali festival, we have to ignite some crackers. The mechanism of this rocket launched with help of Newton's third law of motion. Number 2, when a bullet is fired from a gun, the gun moves backward side. It is based on Newton's third law of motion. Action and reactions are simultaneously. So these are some examples of Newton's third law of motion. Then next point we have to understand or we have to study the law of momentum, conservation law of momentum. Look at this. Next point, conservation law of momentum. conservation law of momentum. In last period, we have to start the Newton's first, second, and third law. Now we have to discuss about Newton's law of momentum. We know that momentum is the product of mass and velocity. P equal to m into v. The law of conservation of momentum, the statement is as when no external force acts on two intersecting objects, then their momentum remains constant. It does not change. Look at this. The statement is as when no external force act on two intersecting objects, then the momentum remains constant. It does not change. Means we have to take two objects A and B. Their momentum, before their initial momentum and final momentum remains constant when no external force apply on these two objects. पहा या नियमामध्ये काय सांगितले, दोन वस्तू एकमेकावर आदळल्यानंतर त्यावर कोणताही जर बाह्यतम बल प्रयुक्त केलं नसेल, दोन वस्तू आदळल्यानंतर, तर त्या दोन्ही वस्तूंचा सुरुवातीचा संवेग आणि शेवटचा संवेग हा सेम असतो, कॉन्स्टंट असतो. मग यामध्ये लॉ काय सांगितला आहे, व्हेन नो एक्सटर्नल फोर्स इज अप्लाय ऑन टू इंटरसेक्टिंग ऑब्जेक्ट, then the total momentum remains constant. It does not change. आपण हे समजून घेऊ या ठिकाणी की दोन वस्तू जर कोणताही बाह्यतम बल आपण लावला नाही, प्रयुक्त केले नाही, तर त्या दोन वस्तूंचा सुरुवातीचा संवेग आणि शेवटचा संवेग हा स्थिर असतो, एक समान असतो. मग याचा आपण एक्झाम्पल या ठिकाणी घेऊ. पहा ए या ऑब्जेक्टचा इनिशियल मोमेंटम m1 u1 आपण म्हणू. बी या ऑब्जेक्टचा इनिशियल मोमेंट m2 u2 म्हणता येईल. m is the mass of object. u1 and u2, these are the initial velocity. Then after the collision, या दोन वस्तू आदळण्यापूर्वी या दोन्ही वस्तूंचा संवेग m1 u1 हा एका पहिल्या वस्तूचा इनिशियल मोमेंटम झाला, दुसरा बी या वस्तूचा इनिशियल मोमेंटम m2 u2. आफ्टर द कोलिजन द मोमेंटम ऑफ ए ऑब्जेक्ट इक्वल टू m1 v1. v1 means final velocity. After the collision of a b object, the momentum of a b object m2 v2. आपला नियम काय सांगितला आहे, या दोन वस्तू आदळल्यानंतर या दोन वस्तूंचा सुरुवातीचा संवेग हा इक्वल आहे आणि नंतरचा पण संवेग हा इक्वल आहे. जर आपण अनबॅलन्स कोणता जर आपण फोर्स अप्लाय केला नाही तर मग आपल्या या ठिकाणी काय सांगता येईल, द मॅग्निट्यूड ऑफ टोटल फायनल मोमेंटम equal to the magnitude of total initial momentum. Therefore final momentum काय लिहिता येईल मग आपल्याला, therefore final momentum m2 v2 plus m1 v1 is equal to initial momentum m1 u1 plus m2 u2. It is the law of conservation of momentum. मग लॉ ऑफ कॉन्झर्वेशन ऑफ मोमेंटम काय सांगतोय, कोणत्याही दोन वस्तू आदळल्यानंतर त्या दोन वस्तूवर जर कोणताही बल लावला नाही तर त्याचा सुरुवातीचा संवेग आणि शेवटचा संवेग यामध्ये कोणताच बदल होत नाही. या ठिकाणी हा नियम आपल्याला सांगता येईल. म्हणजे लॉ ऑफ कॉन्झर्वेशन ऑफ मोमेंटम याचा स्टेटमेंट अजून एकदा आपण समजून घेऊ. स्टेटमेंट काय म्हणता येईल, व्हेन नो एक्सटर्नल फोर्स अप्लाय or acts on two intersecting objects, then the total momentum remains constant, it does not change. So it is about law of conservation of momentum. So we have to complete topic number first. Remaining some example based on equations of motions we have to solve in the next period.